Hey guys, welcome back. Like I said in the previous video, we're going to be looking at this exact same circuit, analyzing it with a mesh current method. So, how this is going to work. Um, I want to kind of go in depth with this problem, so it may be a little bit lengthy, which is fine. A couple things I want to point out. So, with this, I see that I already have this current source sandwiched in between. So if I write my loops, I have no problem defining them, as I've done here. But I do know a special trick called supermesh. So we're going to be utilizing supermesh today to potentially make our lives easier. Again, this is us trying to compare node method to mesh method. And seeing which one saves us more time, is more efficient, and overall which one you like to use. Alright? So, each method has its own advantages. So this one we're going to be doing mesh. As you can see here, I've already defined this as IA, IB, IC, and ID. How this is going to work. Because I have my super mesh, I have to be fairly strategic about how I organize my equations. So what I'm going to do is write a mesh for IA, I'm going to write a mesh for IC, and I'm going to combine a mesh for this super mesh. So what I'm going to do is write a mesh equation in this loop that I've circled. All right. When I do that, I'm going to cut out this source and I'm going to write a constraint equation. So this constraint equation, I want you guys to remember that you always must use when you're using supermesh. Again, I'm going to write my IA, no problem, my IC, just like regular problem solving. But when I see that supermesh, oh no, I have to trap it. All right, I'm going to trap it, and I'm going to write one current in this loop. Alrighty. So without further ado, let's begin. Just some housekeeping stuff. I like to be fairly organized when I solve these. So I'm going to call this loop A. So in loop A, I'm going to follow the direction in which I've defined the current. I've defined it going clockwise, so I'm going to stick with that. So with this, I have my 30 plus my 5000 IA plus my 500 IA minus IB, and I want to show you guys something here. So I have my R, right? And I'm going to have my difference in current. Now, when I'm writing the mesh for IA, I want to have IA be the more positive one, and this one be the conflicting current that goes through this this current right here. Alrighty? So, that is going to be equal to 0. My loop C will be this guy right here. Let's go ahead and do that. My loop C will be a simple one, 80 plus 4000 IC minus IB is going to be equal to 0. Now my super mesh. This one is not super tricky, but it is a super mesh. Alright, that was a lame joke, but we have the super mesh. So when we're doing this, like I said, we're going to trap the current. We're going to trap it in this box. Let's go ahead and write it. We're going to have 1000 ID plus 4000 IB minus IC plus 500 IB minus IA equals to 0. And my constraint. So, my constraint equation is going to be extremely important. So I see that my current is defined in this direction. Take this as law. This current is defined in this direction. Therefore, the way I've defined my IB goes in the same direction as the law. It's law abiding, right? So we're going to give this guy a thumbs up. Boom. He's going in the direction of the 10 milliamp source. My ID is opposing directions. Alright, it's going this way. IB is going this way. So, just like we do for any other problems, we're going to take it step by step. So, my constraint is going to read my IB, and because my ID is conflicting right over here, I'm going to have a minus. Minus ID equals to 10 milliamp. And what I can do right here is, instead of having to write this times 10 to the negative third for the milliamp, I'm just going to go ahead and multiply everything by 100. So I'm going to say that I have 100 IB minus 100 ID equals to 1. And this will kind of make my math a little bit easier and cleaner. Alrighty, so for this, we are going to write out, let's give this a little color code, shall we? So, yellow, pink, and blue. And my constraint, I'm going to put it in black. Alright. Oops. So, for the yellow section, let's go ahead and organize our equations. So, I have my 30 plus my 500 IA plus my 500 IB minus IIA minus IB equal to 0. What I'm going to do is distribute my IA. I'm going to distribute my IBs. I'm going to collect terms and make one cohesive line with IA, IB, IC, and ID. Those are our four unknowns. Therefore, I want to organize my equations in such a way that I get something with IA, IB, plus IC, plus ID equals to 0. Alright, let's keep every term in there. So, we're going to have, for this first one, my yellow section, sorry, that should be a 5500 IA minus 500 IB plus 0 IC plus 0 ID. And that's going to equal to a negative 30. So, something to keep in mind. When I'm writing these, I don't need to put in this 0 IC and 0 ID. It's unnecessary. Just for housekeeping right now, we're going to keep them in there when we're first learning to solve these. Next, I'm going to go to my pink section. When I distribute my 4,000, my IBs, oops, looks like I made a little bit of a mistake here. Let's go ahead and correct that. For my loop C, when I do this, this should actually be a IC right here. 4,000 IC minus IB. That's correct. All right, let's continue. So for this pink section, I should end up getting something that is 0 IA minus 4,000 IB plus 4,000 IC plus 0 ID, and that's going to equal to negative 80. For my blue section, right over here, I should end up, after distributing again, I'm going to end up with minus 500 IA plus 4,500 IB minus 4,000 IC plus 1,000 ID equal to 0. And last, my constraint. My constraint is going to be 0 IA plus 100 IB plus 0 IC minus 100 ID equals to 1. Alright, so we are going to organize this into matrix format. So how I want to do this, I'm going to make a small little model over here of how I'm expecting and how your professor's also expecting you to do this. So we're going to do this as a matrix format. So for the matrix format, I'm going to have my matrix set up like so. I'm going to have my IA, my IB, my IC, and my ID for all 1, 2, 3, 4 equations. All right? And I'm going to model it like so, where I have IA, IB, IC, ID. And that, let me go ahead and shrink this so we have more room. All right. This is going to be equal to the terms that we see here. So like this term, just kidding. I lied. This term, and this term are going to take up this space right here. All right. So I'm going to say val, 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 and val. That's what's going to be on the other side of the equal sign. In turn, when I set up my matrix, I'm going to get a set of values that are exactly IA, IB, IC, and ID. So IA, IB, IC, and ID get returned into this section of the matrix. All right? And these right here, we're going to populate with values. So let's go ahead and make an organized table of everything. And we're going to go ahead and do it on this next slide. In doing this, we should obtain something such as minus 500, 4,500, minus 4,000, 1,000, 5,500, minus 500, 0, 0, 0, so many zeros, minus 4,000, 4,000, 0, a 0 again, a 100, a 0, a minus 100. We're going to close this off. I'm going to go ahead and shrink this so we can get some room. All right, and like I said, IA, IB, IC, ID is going to be equal to our right-hand side. So this is, as I've written it, is going to be equal to 0, negative 30, negative 80, and 1. Now, when solving and plugging into the matrix, we should expect a value that IA equals to minus 0.01, IB should equal to minus 0.05, and these are all amp. IC should equal to minus 0.07 amp, and ID should equal to minus 0.06 amp. Now, keep in mind, the way I've written this is for a different set of IA, IB, IC, ID. It's just rearranging the terms. But all in all, same exact process. Alrighty? So, let's go ahead and do a small comparison of the nodal method versus the mesh method after having gone through both. I'm going to say that right off the bat, nodal method was the way to go. As we can see, oops, we don't have that document. That's okay. As we can see on this section right here, we've done a lot of work, a lot of collecting terms, a lot of organizing terms, a lot of not tedious algebra, but just time-consuming algebra. Whereas when we did the nodal method, we had one equation, one unknown, and everything was solved for. Now, my recommendation to you is to do some digging and look at all the circuits that you've seen up until this point in the semester. If you are able to look at them and identify if nodal or mesh would be the correct method to use, identify which one you think, solve it. Go ahead and time yourself, figure out, hey, this took me 10 minutes versus 20 whole minutes to do a mesh. Your choice. If you have any questions about anything in the video, again, feel free to comment and I will get back to you as soon as possible. Alrighty, thank you.